Okay, so today's new topic comes to us from 2.1 in the book, Power and Radical Functions. We want to be able to graph and analyze power functions, which is not all that different than what we've been doing with function analysis so far. We also want to be able to find domain and range for radical functions and solve radical equations. And radical, remember, just means things like square roots, cube roots, all of the roots that become functions are considered radical functions. Okay, so go ahead and grab whatever you're using to take notes, and let's get started. 2.1, power and radical functions. Okay, so power functions are basically monomials that have different powers of x attached to them. So for example, a power function might be something like f of x equals like 2x to the fourth, or x to the 1/2, or the square root of x, or x to the 256th. Anything like that would be considered a power function. Any monomial, pretty much, with x to some exponent. So we want to be able to graph and analyze these types of functions. So this is most easily done just with an example, and then because it does kind of go over most of the things that we've already done. So for this particular one, we're going to go f of x equals 1/3 x to the third. All right. And power functions don't necessarily have to be, or they're kind of a broad category. But yeah, anyway, it's a broad category, but it encompasses all these radical functions that we'll talk about as well. But this one we're going to talk about is not a radical function. It's just a power function. So if we were going to graph and analyze and stuff like that, 1/3 x to the third, we could graph it. First of all, Desmos would be a good option, or a TI calculator for graphing. And the things that we're going to be asked are pretty much the same things that we've been asked to find in Chapter 1. Things like domain, range. So I'm just going to write down all the things we want to find over here. Intervals of increase. Intervals of decrease. The y-intercept, the zeros, the end behavior. And then continuity as well. Okay. So these are pretty much all the things that we will be asked to do and to find. And again, using a graphing calculator is what we're going to end up doing to find all of these things. So if we go to Desmos. And we type in 1/3 x to the third. Take a moment and try filling in those things: the domain, the range, the increase, the decrease, y-intercept, zeros, end behavior, and continuity. Since this is kind of a refresher of the first part of Chapter 1. Once you think you have those things, type done in the chat. Oh, and for continuity, all we're asking really is it continuous or not continuous? As you go through this, the first part, I've put up the first half. So if you want to check your answers, you can. I have the domain and the range are both negative infinity to positive infinity. There's no excluded values on the domain or range here. Increase is also negative to positive infinity because this function is always increasing and never decreasing. So there is no interval of decrease. And remember, with end behavior, we're looking for the limit as x goes to negative infinity. What's the left arrow doing? And then the limit as x goes to positive infinity. What's the right arrow doing? So the left arrow is going down to negative infinity. The right arrow is going up to positive infinity. And there is only one intercept. And it's the same for y and x. They're both 0. And this function is continuous. Okay, so that's the kind of thing that we're looking for with analysis of power functions. Okay, so hopefully that looks very similar to what we've done from chapter 1, because we are going to move on to radical functions. And equations. Okay, so any function with a radical sign. So a square root, a cube root, a fifth root, a 98th root. Anything with a root like that is going to be considered a radical function. It's anything that can be written in the format of f of x equals a times the nth root of x. So this a can be any constant value, n can be any whole number. Okay, so it's kind of it's a subset of the power functions, because technically a power function is anything that can be written as f of x equals a x to the n, which encompasses the radical functions because x to the 1/2 power is really the square root of x. those are the same. So then this is that subset of the power functions. And so what we mostly want to be able to do is, well, we want to be able to find domain and range of power functions, or of radical functions, because sometimes it is different than your standard power function like x cubed. And then we also want to be able to solve radical equations. So first we'll do an example with domain and range. We'll say f of x equals -3 root 2x plus 9 minus 2 on the outside. And we want to find domain and range. And what I would do again is plug it into Desmos. Also a shortcut, if you didn't know already, typing sqrt into Desmos gives you a square root. If you don't want to use their little keyboard. All right, so that little starting point there tells us a lot about our function, and in particular the domain and the range, because if we zoom out, this thing looks like this. So it has a clear starting point where there's no y values that are higher than this, and there's no x values that are lower than this. So my lowest x value is going to be -4.5. So when I'm writing my domain, it's going to be including -4.5 to infinity. And then my range is going to be all the y values up until -2. So it's going to be -infinity to -2. So my domain, -4.5 to infinity. And then my range, -infinity to -2. So that's where domain and range of radical functions looks a little bit different. Just because it has to do with all of the things underneath the square root not being able to be negative. Okay, so there's domain and range of radical functions. Basically, find the starting point, and then finding the domain and range from there. Okay, the thing that we really want to focus on today, though, is radical equations, because those tend to take a little bit of work to learn to solve. They tend to be a little bit more puzzling anyway. So, radical equations. So for this first one, we're going to say 3 equals the cube root of x squared minus 2x plus 1. That's all underneath the cube root. And then we're going to have -1 on the outside. And we want to solve for x. Okay. So the first step, if you can, we want to consolidate everything so that there's whatever the root is, that it's on one side by itself, and that everything else is on the other side. Because if I were to cube this to start with, then I would have to cube this entire expression over here. I can't just cube each of the terms individually. I would need to cube this cube root -1 as an expression. So I would have to multiply cube root of x squared minus 2x plus 1 minus 1 times this whole thing times this whole thing again. And we would have to do all the double distributing and that involves, which is a lot of work and makes things uglier. So we want to make sure that if we do have anything hanging out here, that we move it over first. So I would start by adding 1 to both sides. So we get 4 equals the cube root of x squared minus 2x plus 1. And now we're all ready to get rid of the root. So now, since I have a cube root, I can cube both sides and get rid of that root. All right, and 4 to the third power is 64. And now we're left with this x squared minus 2x plus 1 over here because the cube cancels out the cube root. All right, so from here, now we just solve this like we would any other quadratic where we have to move this over and factor. So I'm going to subtract 64 from both sides. We get 0 equals x squared minus 2x minus 63. And now we have to factor this thing. So now we're thinking of things that multiply to get negative 63 and add to get negative 2. Well, the only factors that I know of negative 63 that are going to help us here are 9 and negative 7 or negative 7 and 9. Or sorry, positive 7 and negative 9. That was the same thing, just switched around. Yikes. Okay. And in this case, since we want them to add to negative 2, this is the one I'm going to go with. So this factors to x plus 7 times x minus 9. And then we have to set in each of these individually equal to 0. So we go x plus 7 equals 0, x minus 9 equals 0. So this would give me negative 7. This would give me positive 9. So those are my two possible solutions. Now, typically, if it was something like this, if this was the equation that we were solving to start with, not this original one up here, we would be done and rest assured that both of these are solutions to this quadratic here. But since it's a rational function and sometimes, or a radical function or equation, and sometimes positives and negatives behave differently with roots, then we need to check both solutions. So now that we've solved for x, we need to check the solutions. So I'm going to check x equals 9 first. So if x equals 9, what I'm going to do is just plug it back into the original equation here. So we're going to have 3 equals the cube root of 9 squared minus 2 times 9 plus 1 minus 1. So then we just simplify this to check ourselves. So 9 squared is 81 minus 18 plus 1. And 81 minus 18 plus 1 is 64. That minus 1 is still hanging out on the outside. The cube root of 64 is 4. And 4 minus 1 is 3. So once we get down to 3 equals 3, then we're good. We know that x equals 9 is a solution for this equation here. But then we want to go back and check the other one, x equals negative 7. So we would do the same thing. 3 equals the cube root of negative 7 squared minus 2 times negative 7 plus 1 minus 1. All right, so then that would be the cube root of 49 plus 14 plus 1, which is the cube root of 64, which is 4 minus 1, which is 3. So for this one, we also get down to 3 equals 3. So that tells me that both of my solutions work here. So my final answer is x equals 9 and -7. But if one of them or both of them didn't work, then they would be called an extraneous solution. So if one or both don't work, they are called I always forget how to spell that. Extraneous. Okay. And you can't see it. There we go. So if one or both of them were to not work, if you got something like 3 equals 7 or 4 equals 99, they would be called extraneous solutions. So whenever you get an untrue statement down here, that's a sign that that solution does not work. Okay. So looking back at this process here, are there any questions so far? Any steps we're not sure why they happened or why they couldn't have happened in a different order? Any numbers we're not sure where they came from or anything like that? Okay. If you do at any point, feel free to unmute yourself. Yeah, could we use the quadratic equation instead of factoring? Sure, you totally could. That would work. Yeah, so right here, if you like the quadratic formula better, then totally use that. But you will want to start building up your factoring skills again because that's going to come up more and more throughout the next chapter or two. But yeah, anyway, any other questions? Okay, well then let's try another. Let's see. One moment, I can't remember which one I put on. Okay. Okay, let's do this one. We'll do 2 more examples of these because sometimes the steps to solve here take a bit. We'll go 3x equals 3 plus the square root of 18x minus 18. Okay, so this one looks fairly similar to the other one, except it's got a square root instead of a cube root. All right. So the thing that I would do first is move the 3 over because we want to, when we eventually square this, we want to have just this over here to square so that we don't have to do that whole multiplying the entire thing by itself. So I'm going to subtract 3 from both sides. And since these are not like terms, it's just going to sit over here as 3x minus 3. Now we're ready to square it on both sides. And remember, when we square over here, we are going to have to multiply this whole thing by itself. So over here, we end up having to go 3x minus 3 times 3x minus 3 and doing the whole double distributing thing. So 9x squared minus 18x plus 9 is what we should get when we simplify that. And then over here, since the square root and the square cancel, we just get 18x minus 18. Okay, then we're going to solve this one just like we did the last one, moving everything over. So minus 18x minus 18x plus 18 plus 18. And now we have a quadratic. And the nice thing is here, if we're going to factor this versus do the quadratic formula, you can do the quadratic formula here. They're just really big numbers, so it might be a little bit easier if you first factor out a 9, because they all have 9 as the greatest common factor. Okay. And to give us some practice factoring, I'm going to factor this, but feel free to use quadratic formula if you like that better. So we're thinking of things that multiply to 3 and add to -4. The only things I can come up with there would be -3 and -1. X minus 3, x minus 1, and then we still have that 9 hanging out in front. And then we're setting each of these individually equal to 0. X minus 3 equals 0. X minus 1 equals 0. So that gives me 3 and 1. And then just like last time, we're going to go back and check. So we're checking x equals 3, so we would get 3 times 3, because we're dealing with that first equation here, equals 3 plus the square root of 18 times 3 minus 18. And this whole thing simplifies to 36. So the square root of 36 is 6. And 3 plus 6 is 9. So 9 equals 9, and we're all good. X equals 3 is a solution. All right, and then we do the same thing with x equals 1. 3 times 1 equals 3 plus the square root of 18 times 1 minus 18, which is the square root of 0. And 3 equals 3. So we do get the same thing here where they are both solutions. And that one was a very similar way of solving. So a lot of these you'll kind of start to notice there's sort of a pattern to how they solve. Any questions with this one so far? Okay. The next one that we're going to do, we'll take it up a notch. And this one also, let's see. Yeah, this is another case where I think both solutions end up being valid, but it's a slightly harder version of it. So let's take a look at that. Because this one's going to have a square root on both sides. So we're going to have the square root of x minus 2 equals 5 minus the square root of 15 minus x. So we are going to deal with the square root on both sides. Okay. So when you have a square root on both sides like this, what I would do, you're going to end up having to square one of the sides and then just deal with having a radical for a bit. To get rid of one of the radicals, you're going to have to square it and have this radical remain in the equation for longer until you can also get rid of that one by squaring again. So we're going to end up having to square twice. So this one's going to take a little bit more space. So the first thing I would do here is square both sides. So over here, we're left with x minus 2. Over here, we would end up having to multiply 5 minus square root of 15 minus x times 5 minus square root of 15 minus x. Okay, so 5 times 5 is 25. I'm going to treat this kind of like it's an x in a way. Like when you go through and multiply, I'm just going to leave it as minus 5 times root of 15 minus x, and then minus 5 times root of 15 minus x again. And then this thing times itself would just be plus 15 minus x, because it's a square root times a square root. So what we end up with is 25 minus 10 root 15 minus x plus 15 minus x. Okay. So now what we want to do is get this square root right here by itself so that we can square the whole thing again and get rid of all of the roots so that we can solve for x. So I'm going to move everything that doesn't have this square root in it onto the other side. So I'm going to add x to both sides. Let's see, 25 and 15. So we'd go minus 15 and minus 25. So basically we're moving everything over. So we have 2x over here, and then negative 2 minus 15 minus 25 gives us minus 42. Okay. So that's what we're left with. And now we've got the square root over here with nothing else attached to it. So we can now square both sides again. Okay, so if you have multiple square roots at the beginning, you may end up having to square things more than once. Isn't that fun? So remember, when you have two things that are multiplied and squared, you have to give the square to both of them. So negative 10 squared is 100. The square root of 15 minus x squared, those just cancel. So we are left with 15 minus x right there. And then over here, we do have to multiply 2x minus 42 times 2x minus 42. Which is super fun to multiply. We are going to get 4x squared. And then let's see, 42 times 2 again, minus 168x. And then it's 42 squared, 1,764. Okay. And somehow this one still does work out nicely. Okay, So then what I would do is distribute the 100 through. So we get 1,500 minus 100x. And then I would add 100x to both sides. And subtract 1,500 from both sides. So that we get 4x squared minus 68x plus 264 equals 0. Which is starting to look nicer, right? Okay, now this ends up working the same way as the previous two did, where we can now factor this thing. So first we take out the GCF of 4. Wait, that might not be, no, it's 17, just kidding. 17x, and then plus 66 equals 0. And then we are looking for things that multiply to get us 66 and add to get us negative 17. So let's see. We can do something with 11 and 6. 6 times 11 is 66. Or you could use the quadratic formula at this point. This might be a decent place for that if thinking of things that multiply to 66 is not your thing. In this case, though, I would want to do negative 11 and negative 6 because those add to negative 17. So we get 4 times x minus 11 times x minus 6. So then setting each of these equal to 0, we would get x equals 11 and x equals 6. And then I would want to go back and plug those into the beginning to check them. So we would go square root of 11 minus 2. And then 5 minus the square root of 15 minus 11. 11 minus 2 is 9. The square root of 9 is 3. 15 minus 11 is 4. The square root of 4 is 2. And we get 3 equals 3. So we're all good there. And then we would check x equals 6. So we'd have the square root of 6 minus 2 equals 5 minus the square root of 15 minus 6. 6 minus 2 is 4. The square root of 4 is 2. 15 minus 6 is 9. The square root of 9 is 3. 5 minus 3 is 2. So our solution would be both x equals 11 and 6. Okay. So the hardest part about that is probably wrapping your mind around multiplying that through, or even just knowing to do that in the first place. So when you do have more than one radical, that's a helpful step to take. Any questions on that one? Any steps we want to go back to? Any numbers we're not sure how they got there? Anything like that? What happens to the 4 that was factored out? Good question. So when we set this equal to 0, either of these being equal to 0 would give us, would be a solution to that equation. So nothing really happens with the 4. It's just not really a necessary part because 4 is never going to be equal to 0, so no solution comes out of the 4. So yeah, after you factor it out, you don't really have to do anything with it here. Any other questions, concerns at the moment? Okay. Let's see. All right. Let's see. So we've got a little bit of time left here. I'm gonna have you guys try one. Let's have you guys do the cube root of 4x plus 8 plus 3 equals 7. Okay, so go ahead and give that one a try. When you think you've got it, type done in the chat. If you move the 3 over first, you're on the right track. And then cube both sides. This one's only going to generate one answer, so if you're worried why you don't have 2, it's okay, you should only have 1. All right, looks like we're starting to finish up here. If you finish, go ahead and check your work here. If you got x equals 14, you are correct. If you got something else, go back through and check your algebra. Okay, so for those of you who are done, I'm going to start by posting the assignment for today. If you're not done yet, don't worry. We still got some time. Okay, and this one only generated one answer because there was no x squared or anything like that under here, and there was no x over here that when we square or cube for anything over there to end up being x squared or anything like that to make it a quadratic. So we should get x equals 14. When you plug it in and check, it does work, so that is our solution. Okay, so today's assignment is going to be in IXL, everybody's favorite. There are two sections today. One of them is about the domain and the range of radical functions, and then the other one is about solving radical equations. So when they ask what is the range of this function, since this function is only below the x-axis, it starts here at 0, 0, it's going to be y values less than or equal to 0. This one, though, starts up here at 5, so it's going to be y values less than or equal to 5. Okay, so that's how that one goes. And then we also have solving radical equations. So the first ones like this are on the simpler side where you just square both sides first and then add 2 to both sides and you're done. But then we end up with things like this where you do have to add 6 to both sides before you do anything. Or things like this where there's more than one thing underneath the radical. So as you go, it just kind of increases in number of steps. Okay. So that is your assignment for today. I will also post an exit ticket in a couple of minutes. You've got some time in class now to work on it, though. So if you have questions, stick around. If you do not have questions, feel free to go get to work. I will be here for the rest of the period on this Google Meet. But yeah, if you have no questions, have a wonderful Monday.